If you traveled 10,000 years into the future, what would planet Earth look like? Would most of its surface be covered in volcanoes? Or would it be frozen in ice? What if you traveled even further, to 1 million years in the future? Would all of the oceans have evaporated? Or would it have become one giant water world? Now, what about 1 billion years? Would there be any humans left? Or would they have settled in other parts of the galaxy? Let's face it, the chances of any humans being around to greet you when you arrive 1 billion years into the future are pretty low. Several key existential threats face the human race, and if we want to be around in 1 billion years, we'll need to endure them all. We've seen how much we've struggled to come together just to survive a global pandemic. So how do we have any chance of enduring the threats of climate change, overpopulation, global nuclear war, killer asteroids and comets, natural ice ages, and the sun getting a lot hotter? Well, let's take a look into the future and find out. Just under 10,000 years from now, we're going to run into a big problem called the Deca-millennium bug. At 10,000 AD, software encoding the AD calendar year won't encode dates with more than 4 decimals. Remember Y2K? Yeah, it's just like that. Except hopefully we won't panic as much this time around. On the bright side, in 10,000 years, genetic differences and traits between humans will no longer be regional. Traits like skin and hair color will be evenly distributed around the globe. Maybe that will help all of us get along, finally. 20,000 years into the future, none of the current languages will be recognizable. Future languages will only contain 1% of the core vocabulary words of their present-day counterparts. 50,000 years from now will mark a new glacial period for Earth, which will start a new ice age. Niagara Falls will have eroded into Lake Erie completely, and interestingly, a full day on Earth will also increase by 1 second at this point in time. Wow, so much more time for activities. In 250,000 years, the Lo'ihi volcano will rise above the water to form a new island in Hawaii. In 500,000 years, it's likely an asteroid with a diameter greater than 1 kilometer, or 0.62 miles, will hit the Earth unless we can prevent it. The resulting crater will be no less than 400 kilometers, or 248 miles across. It'll start fires all over the planet and make the air unbreathable. So there's something to look forward to, I suppose. And in case that's not enough, in 1 million years, we'll likely have another supervolcano eruption large enough to spew out 3,200 cubic kilometers, or 720 cubic miles, of ash. It will produce enough lava to fill 75% of the Grand Canyon. This would be similar to the Toba eruption that almost wiped out humanity 70,000 years ago. Oh, and the nearby star Betelgeuse will have exploded into a supernova by this time, making it visible from Earth even during the daytime. In 2 million AD, humanity will have settlements throughout the solar system, assuming we didn't wipe ourselves out. This also means that if populations on different planets have remained separate, humans may have evolved into other species adapted to their specific world. In 10 million years, a huge part of Eastern Africa will break off, forming a new ocean basin. In 50 million years, Africa will collide with Eurasia, closing off the Mediterranean Sea, and a new mountain range will form between the two landmasses. This mountain range may include a mountain taller than Mount Everest. In space, Mars will collide with its moon, resulting in it developing a ring system like Saturn's. In 60 million years, the Canadian and American Rockies will have eroded entirely. In 80 million years, all Hawaiian islands will be below the water. In 100 million years, an asteroid similar to the one that killed the dinosaurs 66 million years ago will likely hit Earth, one that is 10 kilometers or 6.2 miles wide. In 250 million years, all of Earth's continents will be fused together like Pangea, except this time, it'll be called Pangea Ultima. But don't get too attached to it, because in 400 to 500 million years, Pangea Ultima will be separate again. In 500 to 600 million years, a gamma ray burst will likely occur within 6,500 light years from Earth. If that strikes Earth, it could damage the ozone layer and trigger a mass extinction. 600 million years from now, the moon will be so far from Earth that total solar eclipses will no longer be possible. The sun's increasing luminosity will have raised temperatures on Earth so much that it could halt plate tectonics movement. In 800 million years, carbon dioxide or CO2 levels will drop dramatically, and photosynthesis will no longer be possible. Free oxygen and ozone will disappear from the atmosphere, and complex life on Earth will die. And finally, in 1 billion years, the sun's luminosity will have increased by 10%, and the average temperature on Earth will be 47 degrees Celsius, or 117 degrees Fahrenheit. Our atmosphere will feel like a damp greenhouse, and our oceans will evaporate, leaving just pockets of water at each of the poles. When you arrive here in your time machine, be mentally prepared to take in a planet Earth that looks nothing like the one you remember. The human race will be gone, hopefully living its best life on some other far-off planet. Because of the intense heat, lack of water, and lack of breathable air, Earth will be uninhabitable, so you probably shouldn't stay too long. Instead, you should head out to see the rest of the solar system. Earth and Mars may become tidally locked with the expanding subgiant sun. The Earth and Moon are very likely destroyed by falling into the sun, just before the sun reaches the tip of its red giant phase at its maximum radius of 256 times the present-day value. Before the final collision, the Moon possibly spirals below Earth's Roche limit, breaking into a ring of debris, most of which falls to the Earth's surface. During this time, most of the Earth's atmosphere will be lost to space, and its surface will consist of a lava ocean with floating continents of metals and metal oxides, as well as icebergs of refractory materials, with an average temperature of over 2,400 degrees Kelvin, or 2130 Celsius, or 3,860 degrees Fahrenheit. During this era, Saturn's moon Titan may reach surface temperatures necessary to support life. The sun reaches the tip of the red giant branch of the Hertzsprung-Russell diagram, achieving its maximum radius of 256 times the present-day value. In the process, Mercury, Venus, very likely Earth, and possibly Mars are destroyed. There is a roughly 1 in 100,000 chance that the Earth might be ejected into interstellar space by a stellar encounter before this point, and a 1 in 3 million chance that it will then be captured by another star. Estimated time, the end of the universe via the Big Crunch, assuming a closed model. Depending on how long the expansion phase is, the events of the contraction phase will happen in the reverse order. Galaxy superclusters would first merge, followed by galaxy clusters, and then later galaxies. About 100,000 years before the Big Crunch, stars have become so close together that they will begin to collide with each other. Also, the cosmic microwave background temperature will rise to about 100,000 Kelvin, or 100,000 degrees Celsius, or 180,000 degrees Fahrenheit, which means that stars will no longer be able to expel their internal heat, slowly cooking themselves until they explode. Minutes before the Big Crunch, the temperature will be so great that atomic nuclei will disband, and the partials will be sucked up by already coalescing black holes. Finally, all the black holes in the universe will merge into one singular black hole, containing all matter in the universe, which it would then devour the universe, including itself. After this, it's possible that a new Big Bang would follow and create a new universe. The observed actions of dark energy do not support this scenario. However, the properties of dark energy are still not known, so it's possible that dark energy could reverse sometime in the future. The universe's expansion, assuming a constant dark energy density, multiplies the wavelength of the cosmic microwave background by 1029, exceeding the scale of the cosmic light horizon and rendering its evidence of the Big Bang undetectable. However, it may still be possible to determine the expansion of the universe through the study of hypervelocity stars. High estimate for the time until normal star formation ends in galaxies. This marks the transition from the stelliferous era to the degenerate era. With no free hydrogen to form new stars, all remaining stars will slowly exhaust their fuel and die. 110 to 120 trillion years from now, the stellar mass objects remaining are stellar remnants, white dwarfs, neutron stars, black holes, and brown dwarfs. Collisions between brown dwarfs will create new red dwarfs on a marginal level. On average, about 100 stars will be shining in what was once the Milky Way. Collisions between stellar remnants will create occasional supernovae. Estimated time for the Boltzmann brain to appear in the vacuum via a spontaneous entropy drop. The chances of this happening are so small that the last star will die long before it happens. However, the vast majority of our universe's life will take place not before, but after all the stars have died. Thank you for watching, and please hit the like button, subscribe to the channel, and enable post alerts to view more of our future videos. After saying that, keep watching our videos, and I'll speak with you in the next one.